Welcome back to another video in the Descriptive Statistics series. Data refers to the facts and figures that are collected for analysis, forming the foundation of any statistical study. A data set is the complete collection of this data specifically gathered for a particular study, encompassing all relevant information. Within this data set, elements are the individual entities on which data is collected, typically represented as rows in a table. Each element is characterized by variables, which are the specific characteristics or attributes being measured, represented as columns. An observation refers to the complete set of measurements for a single element, essentially a list of values for all variables associated with that entity. Together, these components help organize and structure the data for effective analysis and interpretation. Data can be classified in several ways, each of which influences how it can be analyzed and interpreted. First, data can be categorized by its scale of measurement, which includes nominal, ordinal, interval, and ratio scales. Second, data can be classified as quantitative or categorical. Quantitative data consists of numerical values that can be measured and quantified, like age or salary, allowing for various mathematical operations. In contrast, categorical data represents characteristics or attributes that can be divided into groups or categories, like types of vehicles or responses to a survey question. Third, data can also be classified based on how it was obtained, distinguishing between cross-sectional data, which is collected at a single point in time, and time series data, which is collected over various time periods. The type of data significantly affects the amount of information it contains and dictates the appropriate methods for summarization and analysis. For example, it would be inappropriate to calculate an average for a categorical variable like gender, as it does not possess a numerical value that can be averaged. Understanding these classifications helps researchers choose the right statistical techniques for analyzing their data effectively. As stated before, data can be categorized into four main types based on their scales of measurement: nominal, ordinal, interval, and ratio. Nominal data consists of labels or names that categorize observations without any inherent order. For example, consider a dataset representing different types of sports, such as soccer, basketball, swimming. These names can be assigned numbers like 1, 2, 3, but the numbers do not imply any ranking. They are merely identifiers. Ordinal data includes a meaningful order or ranking among the values. A great example is the ranking of medal winners in a competition: gold, silver, bronze. Here, the order matters. Winning a gold medal is better than winning silver, which is better than winning bronze. However, while we can rank these medals, the difference between them isn't uniform. We cannot quantify how much better the performance was for the gold medalist compared to the silver medalist. Interval data extends ordinal data by being numeric and allowing meaningful differences between values. For example, in temperature measurements, like Celsius or Fahrenheit, we can say that a temperature of 30 degrees Celsius is 10 degrees Celsius warmer than 20 degrees Celsius, but 0 degrees Celsius does not indicate the absence of temperature. It is just a point on the scale. Ratio data includes all the characteristics of interval data but has a true 0 point, allowing for meaningful comparisons of ratios between values. This means we can say that a value of 10 kilograms is twice as much as a value of 5 kilograms. Examples of ratio data include measurements like distance, meters, height, centimeters, weight, grams, and income, dollars, where a value of 0 truly represents the absence of the measured quantity. For example, 0 meters means no distance. Understanding these classifications is essential for selecting the appropriate statistical techniques for analysis and ensuring accurate interpretation of the data. Data can be classified into two main types: categorical, qualitative data, and quantitative data, each with distinct characteristics and applications. Categorical, qualitative data. Categorical data consists of labels or names, which can be either numeric or textual. The values of a categorical variable are drawn from a specific list of labels, such as yes, no, or red, green, blue. This type of data can be further categorized into nominal and ordinal scales of measurement. Nominal data has no inherent order, for example, colors, while ordinal data does have a meaningful ranking, for example, ratings like poor, fair, good, excellent. Ordinary arithmetic operations, such as addition or averaging, are meaningless for categorical data since the categories are not numerically quantifiable. Consequently, the statistical analyses appropriate for categorical data are limited, often focusing on frequency counts or proportions rather than more complex calculations. Quantitative data. In contrast, quantitative data is always numeric and can be further divided into discrete and continuous types. Discrete data represents countable values, for example, the number of students in a class, while continuous data represents measurable quantities that can take on an infinite number of values within a range, for example, height or weight. Quantitative data uses either interval or ratio scales of measurement. In this case, ordinary arithmetic operations such as addition, subtraction, multiplication, and division are meaningful, allowing for a wide range of statistical analyses. Most statistical techniques are designed for quantitative data, enabling researchers to perform detailed analyses, draw conclusions, and make predictions based on numerical relationships. In summary, the distinction between categorical and quantitative data is crucial in statistics because it determines the types of analyses that can be performed and the meaningfulness of various mathematical operations applied to the data. Data can be classified based on how it is collected over time, resulting in two main types: cross-sectional data and time series data. Cross-sectional data is collected all at the same point in time, or it can be considered not time-varying. This type of data captures a snapshot of various subjects or entities at a single moment. For example, if you collect a list of student names along with their heights in a particular class, you are gathering cross-sectional data. All the height measurements reflect the same time frame, providing a view of that specific moment without considering how those heights might change over time. This data type is useful for comparing different subjects or entities within the same time frame. In contrast, time series data is collected over several time periods, allowing for analysis of how variables change over time. An example of time series data would be monthly sales figures for a company over the past 5 years. Each data point is associated with a specific timestamp, which is crucial for analysis. Time series data helps researchers understand historical trends, patterns, and behaviors, making it possible to identify seasonality, cyclical changes, and long-term growth or decline. By analyzing this data, one can project future trends and make forecasts based on past performance. This type of analysis is essential in various fields, including economics, finance, and business planning, where understanding changes over time is critical for decision-making. In summary, the key difference between cross-sectional and time series data lies in the temporal aspect. Cross-sectional data provides a snapshot at a single point in time, while time series data offers insights into how variables evolve over multiple time periods. Thank you for watching this video.